Hello, here's an honors topic for Algebra 2. This is going to be dealing with long division of polynomials. So this is, and I made some mistakes with my exponents, so I'll read this through for you. We're going to divide 3x to the 4th minus 5x cubed plus 4x minus 6 by x squared minus 3x plus 5. So we set this up like you would have in any other long division in your entire life. We put this part on the outside, so x squared minus 3x plus 5. And then we set up that long division bar. What's underneath of it comes this polynomial. But just like in synthetic division, we have to figure out if we need any zero placeholders. That's if we skip a degree or an exponent. We go from 4, 3 to 1 to nothing. So we're skipping the x squared part. So we need to add that in. So we're going to have 3x to the 4th minus 5x cubed plus 0x squared plus 4x minus 6. So the way that we perform, we take our very outside term of our divisor and we say, we want to know what times this term will equal my first term. So x squared times what will give me 3x to the 4th? That will be 3x squared. Now test yourself. X squared times 3x squared gives me 3x to the 4th. If you're having trouble with this, something you can say is, all right, give me my first term. That's 3x to the 4th. And you can actually divide it by your outside term, x squared. I get 3x squared. Magically, that's the number I chose to put up here. So you can think about this in any way. The way I would prefer you to, because you're thinking about this more mathematically, is by saying, what can I multiply this number by to get this number and put that number up top? If you're doing the division way, that's more than okay. I don't care. It's whatever makes sense to you. Always go with what is better in your head. Just know I won't do this way. I'll show you the other way. So this way is always an option if you need to do that on your own. So after we figure out what number goes up here, now we multiply each one of these terms by that number. So x squared times 3x squared gives me 3x to the 4th. Negative 3x times 3x squared gives me negative 9x cubed. 5 times 3x squared is 15x squared. So after this part of long division, we have this little saying that says draw the line and change the sign. So you want to change the sign of every single one of these terms. If we take 3x to the 4th plus negative 3x to the 4th, those cancel. Negative 5x cubed plus 9x cubed leaves me with 4x cubed. 0x squared minus 15x squared, negative 15x squared. And now I'm going to bring down my 4x and my negative 6. So that's one full cycle of long division. Let's keep going now. X times what gives me 4x cubed? 4x will give me 4x cubed. So now we multiply. Again, you could have done 4x cubed divided by x squared. That equals 4x, so that number goes up top. Whatever way works. X squared times 4x gives me 4x cubed. Negative 3x times positive 4x. Negative 12x squared. 5 times positive 4x, that's positive 20x. Draw the line, change the sign. These cancel. They should cancel every time. If they're not, you're doing something wrong. 15x squared plus 12x squared. This was a negative 15, so I'm ending with negative 3x squared. 4x minus 20x, negative 16x. And bring down the 6. Okay, one last time. X squared times what gives me negative 3x? That's just negative 3. Now we multiply x squared times negative 3, negative 3x squared, negative 3x times negative 3, positive 9x. 5 times negative 3, negative 15. Draw the line, change the sign. So I shouldn't have put the plus sign because I need to change that to a minus. And then change that to an addition. Again, cancel. Negative 16x minus 9x. Again, so we're at negative 16 and we're going more negative. It's going to take me to negative 25x. Negative 6 plus 15 is going to give me the positive 9. So now tell me, can I multiply x squared by anything to give me negative 25x? The answer here is no, because I can't multiply x by x squared by something to give me a lower version of x. So since this cannot be divided anymore, this is my remainder. So what we do is we take what's on top, which is 3x squared plus 4x minus 3, and we add it to our remainder written over top of our divisor. And that would be our final answer. So what I'll say is you won't always see it written out this way. This is what sets long division apart. So in class as a whole group, we're going to talk about synthetic division. But if you're ever faced with something larger than a linear function, you cannot use synthetic. So since this is an x squared, I have to use long division. So now I'm going to show you a version of something that we could use synthetic division for, but I'm going to have you use long division. I could use synthetic because it's just a linear. There's no exponents here, but these are a little bit simpler, not quite as hectic of long division to do. So I just want to show you one more example this way. X minus 2 goes outside, and check for any 0 placeholders. 3, 2, 1, nothing, so I'm okay. Go ahead and set this up and start our long division process. So x times what gives me x cubed? That will be x squared. X times x squared, x cubed, negative 2 times x squared, negative 2x squared. Draw the line, change the sign. Those cancel. 5x squared plus 2x squared. 7x squared. Bring down my other terms. So negative 7x plus 2. X times what gives me 7x squared? That is positive 7x. Multiply those out. X, 7x, 7x squared, negative 2, 7x, negative 14x. Draw the line. Change the signs. Again, cancel. This leaves me with positive 7x. Bring down the 2. X times what gives me 7x? That is 7. X times 7, 7x. Negative 2 times negative 7, negative 14. Draw the line, change the sign. I'm left with a remainder of 16. X times nothing will ever give me 16. So that will be my remainder. So we write x squared plus 7x plus 7 plus 16 over x minus 2. That's what I divided by. And that would be my final answer. So if you want to try some problems, remember I never collect honors credit homework. There's never like homework per se. There's problems that you can try. So I would try pages 124. You can try any numbers 3 through 10, and those will all be great examples. Okay. Thank you very much.